Welcome to our new course, Science and Torah, Torah and Science. I think over the next 6 weeks we're going to be hearing from Rabbi Dr. Freeman about the connection between the two, the understanding and of controversial questions and thoughts which we might have about the universe and the Torah perspective and the scientific perspective on it as well. We thought we'd have the class downstairs. We thought it'd be nice, small, and intimate, and we'd use the inbuilt projector. Neither is it small or intimate, and neither are we using the projector. So I think for next week, please God, assuming you all haven't been scared by what Rabbi Freeman is going to say, we'll move the class upstairs. As I said, over the next 6 weeks, we're delighted to welcome Rabbi Dr. Moshe Freeman, the Rabbi of Northwood Synagogue, who you've read about his biography, has also got a PhD in science, and really is an expert in the field of both Torah and science, and therefore for a course on those subjects of Torah and science, who better to get than Rabbi Dr. Moshe Freeman? And I'm sure, like all of you, I'm very excited to be hearing what Rabbi Dr. Freeman has to say. Without further ado, Rabbi Freeman.
Thank you very much. I apologize for the late start. No, we'll be Be'ezrat Hashem saying Tehillim for the projector after the talk. But thank God we seem to have everything sorted out, and thank you to those people who tried to sort out the equipment. It's always one of those moments where you think that everything's going to fall apart. Baruch Hashem, we're all here, and we're going to have hopefully a very interesting and complicated question to answer, or set of questions to answer, on science and Torah. This is an issue which has vexed many great minds, far greater than my own, and what I hope to do is to bring you a sort of taste of some of the primary issues relating to one specific question this week, which is the age of the universe, the Big Bang and creation. All of those very detailed subjects, both scientific and both Torah-based, need to be discussed. And without further ado, my mantra for this entire series, and the reason that I've been speaking to so many different groups around London, is because of this. Rabbi Shai Karlinsky, the head of Yeshivat Dar Chinoam, where I studied, he said during one sort of questions and answer sessions with the rabbis, you know, if you want to understand, want to even ask a question relating to science and Torah, you have to make sure that you're learning the science properly, and you have to make sure you're learning the Torah properly. Because if you're missing one of those things, there's no hope for you. There's no hope to be able to understand even the question, let alone try to find a solution or an answer. So what I'm going to do, which may surprise you, is that I'm going to spend at least half an hour teaching you science. I hope that that's okay. I'm going to be very friendly, and this will be a very detailed but clear, hopefully, sort of journey through many of the major issues in specifically how scientists know how old the universe is, how old the sun is, the earth, life on earth, and all of those sorts of things. And the reason I'm going to do that is because we need to have a respect for science before we can have an understanding of the questions with science and Torah. So I'm going to take you through the science first of all. We're going to look at the age of the universe and the Big Bang, the age of the sun, the age of the earth, and also the age of the plants and the animals. Would anyone like the lights to be turned down perhaps a little bit? Is that something that's going to work, or is that going to send everybody to sleep? All right, maybe I'll do that anyway. Everything okay? Okay, good. So let's look at the age of the universe. How do scientists know how old the universe is? The universe is estimated to be 13.78 billion years old, give or take a little bit. Okay, so how do we know? So I'm going to get you to imagine that you're standing here. This is an observer, so the bird's eye view. And this little box here with the blue blocks in it is a police car. And this police car is currently emitting sound. These circles around here are all the sound waves that are coming out from this siren in the police car. The police car's not moving. So when we're listening to the sound of that police car, that siren, it's going off and we can hear it. Okay? What happens, however, when the police car starts to move? So when the police car starts to move, all these little sound waves here bunch up at the front, and the sound waves at the back start to expand. Okay? So sound waves, of course, are just air being compressed, okay, pushed backwards and forwards. So as this police car goes past, we can actually measure the frequency or the pitch of the sound that we're going to hear as the observer. And fascinatingly, what will happen is, because as this police car moves past us, that pitch will go from high to low. Okay? And if you don't believe me, listen to this. Okay, now you've probably experienced this if you've ever been standing on a road when a police car has gone past. This, of course, is known as the Doppler effect. Okay, you probably recognize it. The Doppler effect is very interesting because although it works with sound, it also works with light waves. So if it works with light waves, imagine something that's traveling very fast that's emitting light. The same thing will happen. So let's take, right, the visible spectrum. Okay, here we have the visible spectrum. We have blue at this end. This is a very high frequency. You can see the lines here are very close together, just like a high pitch. And at the end, a very low pitch is equivalent to red light. Okay? And all of the colours of the rainbow in between. Everybody okay with that? Mm-hmm. Good. I'm not going to be testing you at the end. So this very famous scientist, Edwin Hubble, noticed something very fascinating. He was studying the light coming from various stars and galaxies out in the cosmos, and he was measuring the spectra coming from all of these different stars and galaxies. He noticed something very fascinating, which basically changed the face of science and the face of cosmology. So he was looking at the light from our sun and from distant stars, and he noticed the following. Here are two spectra. Now, I'm not going to go into the details as to why they exist, but in all spectra from stars and galaxies, you get these black lines. These are called Fraunhofer lines. These relate to certain elements inside the stars, okay? And they exist in all stars to a greater or lesser extent, and they help us to understand something about the star, its nature, the different elements inside it. But ultimately, when he looked at these Fraunhofer lines, he looked at the Fraunhofer lines from our sun, and he looked at the Fraunhofer lines from supercluster of galaxies. This one is approximately 1 billion light years away. And he looked across the cosmos in all directions, and he noticed something very interesting. All of these lines have shifted towards the red end of the spectrum. Now, what does that tell us? Well, let's change our police car now for a galaxy. So here is a galaxy emitting light in all directions, and if I observe it from here, and I observe it from here, if it's stationary, it will look the same. But if that galaxy is moving, what's it going to look like? Well, because my light waves are bunched up at this end, and they're expanded at this end, this will look slightly blue. The light will be shifted to the blue end of the spectrum, and the light here will be shifted to the red end of the spectrum. So if Hubble is looking out into the cosmos, and all of the spectra from the stars and the galaxies appear a little more red than they're supposed to, what does that tell you? That everything is moving away, that the universe is expanding. Now, this was unbelievable, because until that point, scientists had assumed that the universe was static. The universe had always existed, and it was simply the way it was because it was the way it was, and that was it. And this was the first evidence to show that not only was the universe expanding, but if you rewind the clock, it must mean that the universe had a beginning, which a journalist at the time when all of this came out dubbed the Big Bang. Okay, it wasn't Hubble's idea, that was one of the journalists who coined that term. So if there was a Big Bang, there was a beginning to the universe, suddenly religious people got very excited, because for all time, from time immemorial, from the time of Aristotle, everyone had assumed that the universe just had always existed, was infinite, and therefore the notion of creation itself was a false notion in terms of science. Now, Hubble had produced the evidence that actually there had been a beginning to the universe. So, you know, all the frummers got very excited. However, there was a big problem. There was a big problem, right? I'm not going to bore you too much with the details, but I'll tell you outside. If we can detect the amount of redshift, right, it also means that we can detect the speed at which other galaxies and stars are moving away from our position in the cosmos, okay? Now let's just think about this a minute. Okay, he produced this famous graph, right, here we go. This has got a graph of distance along this axis, okay? We can measure the distance to stars and galaxies in the cosmos using a variety of different methods. We're not going to go into the details now, but that's fairly standard. We can also measure the speed at which those galaxies are moving away, okay? Or those stars are moving away. How can we do that? Because we assume that the magnitude of that redshift is going to relate to the speed at which that star or galaxy is moving away from the Earth. And when he measured the distance and the redshift and he plotted a graph, he found essentially that it came out as a straight line. Okay? If I actually showed you the graph, you wouldn't believe me it's a straight line, but I promise you, it's basically a straight line. And many scientists subsequently have repeated the research and showed that this is a straight line. It's a perfect fit. So that means that if you're a little mathematically minded, the gradient, if you measure the gradient of that graph, it equals speed divided by distance. Now, if I know the speed of something, and I know how far away it is, what else can I work out?
When it started.
When it started. Very good. If I know that a particular car was traveling at 70 miles an hour, and it's gone a distance of 70 miles, right? Just to make the calculation very easy, we know that that car has been traveling for 1 hour. Okay, very simple. So if I plot the gradient of this graph, if I work out accurately from empirical data the gradient of that graph, I can then work out when the beginning of the universe was. Now at this stage, I'll give you a little sort of historical footnote. Scientists had already calculated the age of the Earth to be approximately 4.5 billion years. Unfortunately, Hubble's original work was not terribly accurate, and the calculation that he came to was out by a factor of 10, which in scientific terms is quite large. In fact, he worked out that the age of the universe was actually younger than the age of the Earth, which is quite embarrassing if you think about it. Subsequently, however, the calculations have been redone, and this is more to do with the accuracy of equipment that we now have in terms of measuring the redshift. And in fact, we have a very accurate measurement of the age of the universe, down to 13.78 billion years. Question?
Depending on which direction you're looking,
Yeah.
surely either we're also moving in the same direction
Right.
as those galaxies, but maybe less fast or faster,
Okay.
or we're moving away from them as well. So
Right.
surely that has a factor on the calculations.
No.
Because we're not static.
Right. The reason that it doesn't have a factor is very difficult to explain with words. I have a couple of slides I can show you later, which will explain it. But essentially, the way that the universe expands is not that galaxies and stars are moving as such in the same way that cars are moving. It's that the universe itself, space itself, is expanding. And because space is expanding, it means that everything inside space is also expanding uniformly. And it doesn't matter where you look or where you are, you will look around the cosmos and everything will be expanding uniformly. Okay? And that's a function of the fact that it's space itself that's expanding. And that's because...
Like a balloon inflating.
Yes, exactly, like a balloon inflating. That's because the Big Bang was not the expansion of matter, it was the creation and expansion of space. Okay? Right, so this gradient is known as Hubble's constant. I can't remember if I actually showed you the calculation, but it works out to be approximately 13.75, 13.78 billion years. Okay? Good. So how do we know the age of the sun? How did scientists work that out? Okay. So here is a very more detailed graph of the spectrum of the sun, and you can see again these absorption lines. And essentially the way that scientists can work out the age of any star is by looking at these absorption lines and working out which elements exist in the sun or in any star. So for example, you can go through this graph here and see that this absorption line here, for example, relates to this, and that is a particular element over there. This is sodium, this is iron over here. And by looking at the different ratios of those elements, one can work out the age of a particular star. So that's fairly straightforward. Okay. So the age of the sun is 4.57 billion years. Okay. Now, I'm going to take you into a world of radiometric dating. This is not the same as radioactive dating. That's what happens when the shadchan messes up. But I'm not going to laugh at that. Most people don't laugh at that joke. Anyway, radiometric dating is calculated as follows. Here you have a diagram of a nucleus of uranium-238, okay, which is radioactive. And it's radioactive because this nucleus is unstable. It contains an unequal number of protons or neutrons perhaps, and in order to stabilize itself it will emit certain particles. So in this particular case it will emit 2 protons and 2 neutrons together, which is in fact a helium nucleus. It's also known as an alpha particle, and that alpha particle will be emitted in order to try and neutralize the uranium-238, which is unstable. Okay? This is called the parent nucleus, and this is called the daughter nucleus, and it decays to something called thorium-234. That's one example of many hundreds, perhaps thousands, of different types of radioactive decay. However, this is really useful because radioactive decay occurs at fixed rates depending on what isotope you're looking at, what element you're looking at. So uranium will have a particular decay rate, okay? And because it has a particular decay rate of perhaps millions of years, it means that we can calculate, based on the ratio of uranium to thorium, how old a particular rock or fossil or whatever else you look at is, okay? So I'm going to show you a little live presentation. I hope this works. It usually does. Here I have, there you go. Right, just so that you can see this a little bit more clearly. So it's a bit of glare there. I'm going to turn this on. This is a, here we go. This is a Geiger counter. And if you listen carefully, you'll actually be able to hear the Geiger counter detecting little clicks. You hear that? Right? These little clicks are radioactive events going on in this room. Okay, we're actually being surrounded by radiation all of the time. There's radiation from natural rocks around us, cosmic radiation coming from space. Okay, what I have over here is a little rock that somebody actually dug up from somewhere in Cornwall, and this rock is known as pitchblende, and it contains uranium ore. Okay, you can buy them on eBay, surprisingly, right? But it contains uranium ore, and if I put it to the window of this Geiger counter, okay, you can hear that it's very radioactive. Now, that means that if I was to look at the proportion of uranium to thorium, for example, or other daughter elements in that rock, I can start to calculate how old that rock is. And I'm going to show you what that would look like. Okay, so let's look at this graph. Here you have time across the bottom and the percentage of a particular substance across the side. So the uranium will decay exponentially, just like this. Okay, and it will keep decaying. And we can measure what's called the half-life of this uranium. And the half-life relates to, for example, if you reduce from 100% uranium to 50% uranium, and that's one half-life, two half-lives, and a one half-life could be anything from a matter of seconds or minutes, or it could be millions of years, depending on the element you've got. And of course, subsequently, the stable or more stable daughter element will increase opposite in a proportion, because obviously you end up still with 100% of whatever substance you have. So that means that if I measure the proportion of these two elements, the unstable parent and stable daughter element, I can work out the half-life based on experiments in the laboratory. I can calculate, I can approximate how old the rocks are, okay? Which is very, very useful. So, in fact, what they used to do this for the Earth was to measure the radioactive elements inside a meteorite. And the reason they used a meteorite is because a lot of rocks on Earth are actually younger than the Earth itself. But a meteorite represents the sort of rocky part of the solar system, and the age of the Earth came out to approximately 4.55 billion years. Fossils are very useful because they teach us about life on Earth and how life started. And fossils, in fact, are readily available for free, and if you ever fancy taking a little holiday to Lyme Regis, we actually stayed in Bournemouth, okay, because apparently very few Jews do that for holiday. But we then travelled up to Lyme Regis. Lyme Regis is the fossil capital of the UK. And you can go onto the beaches in Lyme Regis and go fossil hunting. These are the Jurassic coast of the UK. And in between all of these little rocks here, you can pick up fossils just lying on the floor. Unbelievable, particularly if it's been raining and they've been washed out of the sediment. And going on holiday with your kids means that you can take with you smaller people who are able to see things on the ground much more clearly. This is my eldest son, Yeshaya, and he found this, you can barely see it here, this tiny, tiny little fossil, okay, which doesn't even look like anything. If you look at it up close, you can see that it's actually got 5 points to it, and you can just about see these striations in here. This is in fact a precursor to a starfish. It actually is part of a Jurassic cryonoid, and it dates back approximately 505 million years. Sorry, 190 million years. We have a fossil record going back 505 million years. This is a sort of modern example of a cryonoid. It's actually an animal, not a plant. It looks like a plant, but it has a sort of mouth parts over here, and these sort of stems that come out contain these ossicles that go all the way along. So he found that on the floor, and it was a very beautiful little fossil that he found, very small. You can find all sorts of other fossils as well. And of course, what you can then do is take that fossil and measure its age, either from radiometric dating, or what you can do is look at the other fossils around and work out at which period in history and prehistory that fossil came from. Okay, what other indications do we have for the age of the Earth? And in fact, there are some surprising indications that show us that the Earth is significantly longer than we would like to believe, perhaps. Ice cores, very fascinating thing that you spend your life going to Greenland and taking this enormous drill and drilling into the permafrost. You can take out these ice cores over here, and when you polish them up, you can actually see these rings on the ice core. And this is because each season new ice is put down, and you can tell from these rings how old the permafrost in Greenland or wherever you go to is. You can also actually tell something about the environment, the climate at that time as well. So Greenland ice sheets date back approximately 110,000 years. Another example are lake varves. A varve is a sort of ridge of sediment that's put down in a lake. You can just sort of see these ridges here. I've just highlighted them for you. Each ridge is put down once a year, and there is a lake in Turkey which has varves that date back 14,500 years. Okay. Creosote bushes. Okay, I don't know if anyone has traveled in America. These are found in many American deserts. They are phenomenal at absorbing moisture from desert ground. In fact, so much so that nothing else can grow in the desert. But interestingly, these little bushes, these look like individual bushes, but this in fact is one gigantic bush. Because what happens is that the creosote bush starts off in the middle, and it sucks up all the water from around it, and then it can't live anymore. So it puts out roots around it, and the center dies away, and you end up with a ring. And that ring keeps on growing, and it grows and grows and grows, and you can measure the growth of creosote bushes, how fast they grow. This creosote bush, you can actually just see the ring of it here. They've been measured to be somewhere between 10 to 12,000 years, living bushes. Obviously, dendrochronology, which is the fancy word for tree rings, everyone has seen tree rings, of course, and you can actually measure the age of a tree without having to cut it down. Simply, just like we did with the ice core, you bore a hole into it, and you can measure the tree rings from the core that comes out. This is a bristlecone pine. They grow in a number of places. These, I think, are in California. These were measured to be over 7,000 years old. They look dead, but they're not. They're alive. These are live trees. Okay? So we have a problem. We have a very obvious problem, in that science has a very good set of ways of telling a story from the beginning of the universe all the way through to life itself. And the problem that we have is that we have a Torah, and that Torah, together with our prophets and the writings as well, give us a handle on how far back we can go until we get to Adam, and we can actually date pretty much every event as we go through. And we hold that Adam, the first man, was created 5,774 years ago. Okay, that's why the Jewish calendar is at 5774. Rosh Hashanah is the anniversary of the creation of Adam. But if that's true, we've only then got 6 extra days going back to Bereshis Bara Elokim Asa Shamayim V'Yetz Haaretz. So what are we going to do with this? Okay, this is a very big problem. It's not insurmountable, and if any of you have to leave early, please could you tell me, because I don't want your faith to be shaken by what I've just told you. But if we go on, we have to start to try and reconcile this. And there are a number of different ways that we can do that. So what I'm going to do is go through most of the ways that are very popular. I'm going to give my own opinion as to why I think some of them are perhaps more sensible and less sensible. And we can perhaps discuss that afterwards as well. But ultimately, there are a number of different approaches which I want to share with you this evening. So first of all, we can challenge the scientific evidence. We can say that the science must be wrong. Okay, it must be wrong. We've got a Torah, the Torah is true, we believe in God, and if the Torah says, if science says something different to the Torah, then it must be that the science is wrong. And there are many, many people who would do that. Okay? The Lubavitcher Rebbe was well known for writing that all of the scientific evidence can be questioned, and believe me, he was very, very smart. Not only in Torah, he wasn't only a Talmud Chacham, he was very well versed in science.
He was a qualified engineer.
Absolutely. So he knew what he was talking about. Let's read a little bit from Mind Over Matter. The argument from the discovery of fossils is by no means conclusive evidence for the great antiquity of the Earth. In view of the unknown conditions which existed in prehistoric times, conditions of atmospheric pressures, temperatures, radioactivity, unknown catalyzers, etc., as already mentioned, conditions, that is, which could have caused reactions and changes to an entirely different nature and tempo from those known under the present-day orderly processes of nature, one cannot exclude the possibility that dinosaurs existed 5,722 years ago and became fossilized under terrific natural cataclysms in the course of a few years rather than in millions of years, since we have no conceivable measurements or criteria of calculations applicable to those unknown conditions. So, essentially, in a nutshell, the Lubavitcher Rebbe is saying, look, the science has to extrapolate somewhere. We have to look at our data and we have to extrapolate back. And it could be that there were other forces at play which have skewed our data in some way. Okay? That's certainly possible. That's not impossible with most of the data we have. It's a little harder when it comes to things like tree rings and ice cores and things like that. But it's not impossible. However, they did do some studies on particularly radiometric dating, which is often the most controversial of these measurements. And they tried to put certain radioactive rocks under enormous pressures and enormous temperatures to see if it changed the radioactive decay rate. Okay? And there was some change, but very, very little. Certainly nothing that is going to reduce an age of the universe from 13.78 billion years down to 6,000 years. Not only that, but if you actually work the other way around and calculate what the radioactive decay rate would have to look like in order to produce results that are so skewed, it would be so great, it would create enough heat to melt the Earth, according to some studies. So that obviously can't be right. So we're going to have to come up with a better answer. So there is something called the young Earth model. The young Earth model essentially claims that actually the Earth is 6,000 years old, approximately, but scientists have not made mistakes. It's just that the Earth has been sort of artificially aged by God to produce the results that we have. Okay? Now, that's not so silly. First of all, the argument logically makes sense, okay, because you can then answer all of our questions very simply. But actually, the Gemara itself speaks about creations being made in their full form. Okay? Every creation was created in its full form, according to their will, according to their form. Right, let's look at Genesis Rabbah. Rabbi Yochanan said Adam and Chava, Adam and Eve, were created as a 20-year-old. Meaning they were created as fully formed beings. And also the Rashi on the Gemara over there, which I didn't show, says that trees were created as fully formed trees. Now, this idea that the Earth has been sort of artificially aged, in fact, is known as the Omphalos hypothesis. And interestingly, it doesn't have a Jewish source. It has a Christian source. The Omphalos was an attempt to work out a particular problem. It was put forward by a guy called Philip Goss, who was a priest, but also a naturalist. It was explained to me that in the olden days, priests had sort of underlings who would actually take care of all of the pastoral work in their parish, which left them time to sort of play around and do science and all sorts of funky things like that. Sounds like a great model, Rabbi Lehrer, to say. But he writes in 1857, this was 2 years before Darwin wrote On the Origin of Species, an idea, and he posed a question, okay? He said that your fossils are lovely, but it's not proof of evolution, it's not proof of the age of the universe and everything else. Let's see what he says. He asked a question. Did Adam, the first man, have a belly button? Okay? Because assuming that the Torah's account of the creation of Adam was that, God sort of made Adam and boom, there was Adam, he was 20 years old, right? Why would Adam need a belly button? Right? He didn't come from a mother in the same way that each one of us did. So Adam shouldn't have a belly button, but he concluded that God would have created Adam with a belly button. Why? Because even though he didn't need a belly button, God created everything to look like it had a past history. And his logic behind it is very simple. Let's imagine a tree. How do you create a tree? Well, what do? Do you create a seed? Well, what does that seed look like? Where does the seed come from? You need a tree to produce a seed. So if you need a tree to produce a seed, where do you get the first tree from? And so on. And so at what stage do you start that creative process? So he said, fine. God started with a tree, or he started with Adam, a human being, fully formed with a past history. And it ties in with what our sages were saying 1,500 years ago. So expand that to looking at the whole cosmos, the earth, the universe, and everything else. Everything could have been created with a past history that makes it appear older than it is. Okay, I'm not going to read the Lubavitcher Rebbe again, but he essentially concurs with this idea, and he puts that idea forward. Yes.
Where does Darwin come into this?
Okay, we're going to deal with Darwin next time. Darwin, we're going to focus on Darwin and evolution next week because it would be far too much to try and bolt it all together. But we're just looking at the moment, just the age of the universe itself. Yeah.
Does this theory add up to the mathematics?
It doesn't matter.
If the world was created 5,760 years ago, with the young Earth model, it's saying everything's fully formed.
Yeah.
Was it fully formed at X billion years old?
Well, no, it was fully formed with an appearance of being so many millions or billions of years old. It doesn't have to actually have the age. It could just look like that. So when you measure the radioactivity in a rock, it looks like it's 4.5 million years old, or 4.5 billion years old. Right? But really it was created 6,000 years ago. Okay? Now I can see you're very uncomfortable with this idea. But by the way, this is a very popular idea. It's a very popular explanation. And logically, there's nothing you can answer. You can't, it's solid, it's watertight, because any question that you throw at it, you just say, look, God made it up like that. Right? Why did God make it up like that? That's a good question. Now, Rabbi David Gottlieb, who is a serious Talmud Chacham and also very well versed in philosophy and logic, he was trained in logic, he wrote an article called The Age of the Universe. And he basically answers the question as to why God would do something like that. Why would God make a universe and then make it look like it's older than it really is? Now, he says, strictly speaking, we don't have to answer that question. Okay? The fact that that's what happened is all we need to know. Okay? We don't have to provide an answer logically for that argument to be a logical argument. However, he does give a response. He says, nevertheless, even though we don't need to answer the question, we can. Briefly, the purpose of the physical world is to hide God's presence, so that we can exercise free will. In fact, the Hebrew word for world, olam, means hiding. So evidence which hides the true age of the universe since creation would be part of the general policy of hiding God's presence. Okay, so it's to allow us to have free will, to be able to be tempted, so to speak, by a scientific explanation and think that God doesn't really exist, and then to use our free will to believe actually God does exist and everything is real, and the Torah is real, we have to keep the Torah. Okay? That's his answer. Again, it's a very popular idea. Perhaps it doesn't satisfy everybody, but it's reasonable, let's say. However, there has been a response written by a slightly more controversial Rabbi Natan Slifkin, a very interesting writer, and he wrote the following response. He says, according to this approach, God created two conflicting accounts of creation, one in nature and one in the Torah. How can it be determined which is the real story and which is a fake designed to mislead us? One could equally propose that it's nature which presents the real story, and the Torah was devised by God to test us with a fake history. So we don't really know which part is fake. We assume that the Torah is real and the science is fake, but maybe it's the other way around. The idea that God deliberately creates false testimony has disturbing implications. The biblical commentators are quick to point out that when God instructed Abraham to bring up Isaac as an offering, he did not tell him to actually sacrifice Isaac, only to bring him up. Had God genuinely told Abraham to sacrifice Isaac, it would have been impossible for that to have not been his will. In other words, Rabbi Slifkin is saying that when God wants something to happen, when God says something, it's real, it has to be real. God's will is reality. So it's very disturbing to have the idea that God would create something that's false, that's inherently false. Very difficult to reconcile that with Jewish philosophy. Otherwise, he says, perhaps every commandment from him is a test to be doubted. Perhaps he doesn't actually want us to destroy the tribe of Amalek, and it's just a test. One has to be able to rely on God's truthfulness if religion is to function. Or to put it another way, if God went to enormous lengths to convince us that the world is billions of years old, who are we to disagree? Okay. Yeah.
Were these people all putting this forward before we realised that time's actually slowing down?
Say that again, sorry?
Were all these arguments made prior to us, the scientific discoveries, that time is actually slowing?
Right. The idea of time slowing is a different concept. At the time that Philip Goss was writing, they had a very strong handle that the Earth was significantly older than 6,000 years, because they had fossils and they had a lot of evidence of fossils. They also had, there was one, I didn't bring it this evening, but there is one discussion about a particular star that has an orbit of 36,000 years. So if that's the case, then what does it mean that the universe was created 6,000 years ago? It seems like if something has an orbit of that long, it seems like the universe has a greater antiquity. So even at that time when, and this is being fueled by Christian theologians, there was a feeling in the 19th century that the Earth was much older than 6,000 years old. And that was enough to make theologians and philosophers try to find explanations for that. Okay, yeah.
So, according to this logic,
Yeah.
outside of the Torah and Tanakh, what evidence is there that the world wasn't created 5 seconds ago, with all of us having a history that we remember?
Correct. That's an interesting philosophical question and debate, and correct. You're absolutely right. Yeah.
It's interesting.
You didn't answer it. No, it's right. No, the answer is yes. You're right. Yeah.
I mean, leading on from that, what I find fascinating is we get very caught up on time. We ourselves, time is important. We're born, we mature, we age, we die.
Yeah.
Us, change happens. If you want an entity that has existed forever, time's of no consequence. We are the people that make time. Humans have invented time. If you ask a dog what time it is, it will have no concept.
Right. And
the other thing I find quite interesting about science, I have to say it's a very personal viewpoint, is that everything seems to originate from one singularity, one point.
Right. Well, we may get to that point.
God is one.
That point, so to speak, later on.
Fascinating that the figure one is in the very beginning of the universe, all the different energy forms was one source.
Correct.
The energy starts on one source. The universe starts on one source, and I find it very compelling that this number one keeps on appearing.
If we get to it, hopefully in part 6, I can't remember the order that we're doing everything in, we will look at the origins of the universe and the idea of creation ex nihilo, from nothing, and the scientific response to that, because that's a very important point that you've just raised. Again, it's not for what we're doing this evening, but it will come up later. But yeah, you're right. From God's perspective, God stands above time, but the universe that He created does have time, not just human beings. There is a concept of time.
Does
outside.
time actually exist, though? Because
Yes.
we see time.
Yes.
But is it?
Yes, it does. Okay.
All
right.
I think it's something we actually perceive. But I wonder.
Let me ask you a question. If the human race, God forbid, died out,
yeah,
right? Would time still exist? Yes.
I don't know.
Yeah, it would. It would.